In this video, I'll show you what a transformer is, the basic construction of a transformer, and how it works. Let's start the video. Welcome to Star Technology 5G. Transformer. An electrical transformer is a static electrical machine that transforms electrical power from one circuit to another circuit, without changing the frequency. A transformer can increase or decrease the voltage with a corresponding decrease or increase in current. This is the basic shell-type transformer. If we remove this cover, the first part we will see is the iron core. In all types of transformers, the iron core is usually made up of silicon steel laminated sheets and is sometimes heat-treated to provide high permeability and low hysteresis loss. This iron core sheets are cut in the shapes of E and I. The thickness of this laminated sheet is 0.35 millimeters. The core is constructed by stacking the laminated sheets with a minimum air gap between them to achieve a continuous magnetic path. The core is divided into two parts. The top and bottom parts of the core are yoke. The vertical portions are considered to be the limbs. The limbs are covered with windings, and the limb is connected by the iron yoke to form a closed magnetic circuit. This is the plastic tape, used to protect the winding. This is the primary winding. This is also plastic tape. And this is the secondary winding. This plastic part is called a bobbin. Winding is wound on this bobbin. How does a transformer work? There are three essential components in transformers: the primary winding, the secondary winding, and the magnetic core. If the primary winding is connected to an alternating voltage source, an alternating current flows through the primary winding and induces alternating flux in the material of the core. Therefore, voltage is induced in the secondary winding. This is called electromagnetic induction because the current in the primary coil induces voltages in the secondary coil. The operation of the transformer is based on Faraday's law of electromagnetic induction. The rate of change of the flux linkage with respect to time is directly proportional to the induced electromagnetic field in a coil or conductor. When a fluctuating electric current flows through a wire, it generates a magnetic field, an invisible pattern of magnetism, or magnetic flux all around it. If we put a second coil of wire in this magnetic field, and when this magnetic field cut the second coil, it will create an electric current in the second wire. When the primary winding is connected to an alternating voltage source, an alternating current flows through the primary winding and set up an alternating magnetic flux, such that magnetic flux link the secondary winding, then voltages are induced into the secondary winding. This is the basic principle of the transformer. Now you might think about what the purpose of the iron core is. Suppose there is air between the primary and secondary coils of the transformer. In that case, there is only a small amount of magnetic flux linked to the secondary coil of the transformer and a very small amount of induced voltage in the secondary coil. You can see more than 70% of magnetic flux is not linked to secondary coil. If we use iron cores, the ability of iron cores to carry magnetic flux is much greater than that of air. This ability to carry flux is called permeability. If we use an iron core, almost 100% of the magnetic flux from the primary coil circulates in the iron core, so the voltage induced into the secondary coil is equal to the primary coil voltage if the number of turns in the two coils is equal. Modern electrical steels have permeability in the order of 1500, compared with 1.0 for air. This means that the ability of a steel core to carry magnetic flux is 1500 times that of air. Core losses. When magnetic flux flows in the steel core, losses occur in the steel. There are two components of this loss, which are termed eddy and hysteresis losses. When magnetic flux flow in the iron core, they also induce current in the core, and that current is called eddy current losses. If a solid core were used in a transformer, the losses would be very high and the temperature would be excessive. It can be controlled by reducing the thickness of the iron core steel. For this reason, sheets are cut in the shapes E and I. The thickness of this laminated sheet is 0.35 millimeters. To reduce the thickness of the individual sheets of steel normal to the flux and thereby reducing the losses, each sheet is coated with a very thin material to prevent shorts between the laminations. In all types of transformers, the core is constructed by assembling, stacking, laminated sheets of steel with a minimum air gap between them, to achieve a continuous magnetic path. The steel used a high silicon content and is sometimes heat treated to provide high permeability and low hysteresis loss. Laminated sheets of steel are used to reduce eddy current loss. Thank you for watching. Please subscribe to Star Technology. Please like and share the video.